Okay, now that we have the fruit bowl acting as a additional set of hands here, we can go ahead and check out those transistors from the bottom side with each three of these pins corresponding to the transistors we just looked at. And if you can see the meter there, it's set on diode test, and each set of two correspond to one speaker. So we can take a look at that, and we have 0.47, 0.5, and that should be open when we switch it around. 0.47, 0.5. So you can continue this all the way down through all these different transistors, and that checks out. The problem we run into is on this first one, which I believe is the front left. That's just 0, 0, 0. That's a straight connection. And open on that side. 0, 0, 0, and 0, 0, 0. So both of these two transistors are shorted, and you can go down, like I said, all of these and verify that everything else matches the values and the way that these react to the different probes being put on them with a diode test. They all react exactly the same with the exception of these two. If I had to guess, I would say that the speaker wires got shorted when this was turned on. So this is a great example of why you should always have your receiver turned off anytime you're switching wires around, because all it takes is a quick second for those to touch. These are shorted, and now you have to replace these. And if you don't do that, your receiver is basically a paperweight. So in the previous repair that I didn't mention it in the video. It's in the description, but it seems like some people have been missing that. Once you replace those transistors, usually with all that power going through there, what you've done is these resistors that are here have been blown open. So you'll replace the transistors, and this happened on the first one that I did. You replace the transistors, the receiver powers up, you plug your speakers in, and then the sound quality out of whatever channel you repaired just sounds awful. It sounds really scratchy, garbled, quiet. And because you have a multi-channel receiver, you really have the ability to compare resistor values on each separate channel and find which one is the problem. What's really interesting on this one, though, particularly because it's the outside one, we get a good view of it. You don't really need to use a resistor, a multimeter to check it, because you can see once this focuses, this receiver has burned a hole in the side of itself. So way too much power went through here. So when you replace these transistors that we just checked, replace the resistors as well,